Okay, hey, Chris the Carpenter here, rocketbrandstudios.com, with a how-to video on converting your laser cutter to run off of Mach 3. I figured it out, and it is, without a doubt, the easiest way of doing this, and the most foolproof way of doing this, and it's awesome. So, without further ado, this is my laser cutter. It's a full spectrum laser, the 40-watt hobby version, the deluxe. And I blew up a motor driver board, and I needed, because of an extremely long story, I needed this machine now, and so I had to sort of fixify it as it sits. So I chose to fix it by converting to Mach 3. Mach 3. So here is how I did it. Basically, it's a standard CNC setup. Okay, so we've got a parallel, it's off the parallel port. Okay, there's the parallel port coming in. All right, and running off of a parallel board, breakout board, just like a normal CNC. I'm sorry it's dark. The only exception being this one happens to have a relay on it, and that's kind of important. This relay normally clicks the flood coolant on and off, and we'll get to that. And then there's two drivers in there for the X and Y. Those are just cheapy eBay drivers, nothing special about that. Now I'm using the, sorry, it's like winter allergies are freaking killing me. Okay. Stock power supply. Now, okay. All of this stuff is wired to the power supply. So, like, for instance, there's a magnetic switch here as laser protection. The machine won't work unless this lid is closed. That's connected to this. So all that's taken care of for you. And when it all is said and done, I've got one wire coming out, this guy, okay? And this happens to be ground, 24 volts, 5 volts, and laser on off. And it's labeled as such on the board as well, right down in there. And so this is the magic wire. There's one wire. If it's high, the laser's off, and if it's low, if it's ground, the laser's on, okay? So the X and Y is fine. I mean, it's just a CNC, so you just have to set your steps to the proper steps to move the proper amount. So it all comes down to turning the laser on and off at the right times. And there's actually a, you know what, it's the light. Is that better? Light behind the camera. Yay! There are plugins available through Mach 3 to use the spindle control as a PWM speed control, so you can adjust the power going to the laser and all that shenanigans. And the problem being there's a 100 millisecond delay in between the laser coming on and moving. So the laser is burning a hole in the plastic for a tenth of a second, which just seemed asinine to me. And then there's another one that clicks the laser on and off with the E1 P1 command, which apparently is buggy and problematic. I skipped all of that crap, and I made it really, really, really easy. I am switching here it is, listen up, here's the key, ting, ting, ting. I am switching my laser on and off using the Z-axis direction pin. So if the Z-axis goes up, the direction pin goes high, and if the Z-axis goes down, the direction pin goes low, and I'm using that to turn the laser on and off. Problem is, it's a little wonky in how it works. Like, for instance, that direction pin, the direction pin for that Z-axis requires movement. So it's not like you can just set that direction pin and it sets. All right. Now it does latch. So once it's going one way, it'll stay that way until you change it. That's important. But you can't just toggle it back and forth. You've got to do a move. Now, conveniently, most of the things that spit out G-code, I happen to be using PyCam, but this is such a simple cut, it really does not matter at all what you're using. But this is what PyCam spits out. It does this huge deal at the front, which is all of, you know, the information about the cut, bit size and whatever. Within PyCam, I set my bit diameter I just said, the machine thinks it's milling. And I told it the diameter of the bit was 1/1000th of an inch. So there you go. Now here is the trick, okay, right here. This is the first jog to the first location, and then this is the beginning of the first cut right here. So this is the first, so if this was milling, that's the Z to plunge the bit down into the work and start cutting, okay? And that's what you need to remember. Is basically if a laser was a mill, you'd want the laser on when the bit's down, and you want the laser off when the bit's up, right? Well, conveniently, it's basically going to do that for every cut. Like, for instance, here is a rapid, all right, G0, so that's a rapid. And so, in essence, you will raise your bit before you move fast, and then you'll lower it before you cut, right? So, whatever CAM software you're using to spit out your G code, it's already going to have your Z up and downs already, okay? So here's what I do. I go in to edit, where are we? Up here, edit, good old find and replace, and I replace my two Z commands. I change them to Z0 for off and Z negative 0.01 for on. It's a very, very small movement, so it happens almost instantly, all right? But it's enough of a movement to trigger that direction pin. Now, there's a catch in that if you are jogging the machine, or it's kind of luck of the draw what state that direction pin is going to be in when you start up the machine, right? So it could be, the machine could have gone down just happenstance from the last move you made, and so the laser's on, right? Because it moved down and it's still down. So the key is, at the beginning, you need to lower your bit and then raise your bit without the laser actually coming on when that happens. So you're left at the start of your G code with an upward movement, an off movement, turn the laser off movement. So as a safety feature, here's what I did. It's very, 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 very simple. I have this relay that I mentioned earlier that's going off of the flood control for the CNC. So that would turn the coolant on and off. And of the wire, so basically I've got direction, Z direction pin out, going into the relay, out of the relay, and then to the power supply. All right? And so even if that direction pin, whatever that direction pin is doing, it doesn't matter, because if that relay is off, nothing's going to happen. So, and the relay will be off when you fire up Mach 3, and will be off in general. So here's the money shot, okay? Right there. This is at the very, very beginning of my code. If you look right here, this is the first jog to the first position, high speed, right? So what we do is we turn off our relay, turn off the flood coolant, right, with an M9. We probably don't have to turn it off. It's probably already off, but we're sure as hell going to double check, okay? So turn off the relay. That means that whatever you do with the Z-axis, the laser is not coming on, okay? Then lower it, and then raise it, okay? And it's not so much the lower that does anything. It's the raising back up. Because now the last thing we've done is gone up, which we've established the laser is now off because we just made a move upward, okay? And then M8, we turn our flood coolant on. That clicks the relay, and that makes the connection between the direction pin of Z and the laser power supply. And now, since the last thing we did was go up, we now can click this relay on without the laser coming on, because the laser is off due to this upward movement of Z. We rapid to our first spot, and then we move our Z down just a wiggle. That now turns on the laser. The laser just turned on. So here's all of our cuts. Laser turns off. There's a rapid to the next move. Laser turns on. And this Z000 with a rapid in front of it and the Z-1 with a regular move code in front of it. Those were just find and replace. And eventually I'll write a little chunk of code in probably processing as a standalone post processor that will just jink through all of this and fix it all for me so I don't have to do it manually. And then at the very end, your find and replace should take care of these last two. So your laser should be off at the end no matter what, but I added another M9, another flood control to kill the relay, just to be sure. And the rest of this is just scraps. So there is your answer on how to run a laser cutter off of Mach 3. And I can tell you this, I should mention the other thing. My other thought is I was thinking about putting an Arduino in there and programming the Arduino to keep an eye on the spindle speed. Not so much the spindle coming on and off to turn the laser on and off. Obviously, there's that delay, which is the problem. But we can still use the spindle speed to determine the laser's power, which basically means I'd have an Arduino watch the PWM coming out of the spindle pin on the breakout board, on the parallel port breakout board, determine its speed. Also, the laser on-off wire would go into that Arduino, and then the Arduino would turn the laser on and off based on that laser wire, but at the PWM coming out of the spindle, which would just always be running. And then within the code, you could change that PWM. You could turn off the laser, change the spindle speed, the Arduino would change, and then get right back to cutting. And so you could, in theory, change your laser power off of the spindle control without the delay of the spindle coming on and off, which is the main problem with the PWM example that Mach 3 uses. So probably not going to do that now because, well, none of my kits involve engraving, so everything's just a cut, so there's no reason not to. Everything's at 100% anyway, and it's just the speed of the laser to control how the cut goes. And that's it. That's how you run a laser cutter off of Mach 3, and there's no plugins, there's no conversion to the Mach 3 software at all, there's no nothing. All you got to do is just do a find and replace on your G code to change those two Z's to the -01 and the Z0000, and it works. And like I said, you don't even need to do that whole relay thing as a safety measure as long as you're always aware of the last move the Z did, so you know if it's on or off. Because basically, you're not going to realize it's on, and the meter is not going to show anything on the control panel of the machine until you close the lid. And then as soon as you close the lid, that magnet trigger is going to click, the lid close sensor, and it's going to come on, and it's just going to sit there and melt a hole and just burn and burn and burn and burn and burn until you can hit go. And actually, even when you hit go, it's going to still be on when it's jogging to its first location. So you have to be really, you can work without that relay trick, but you have to be really careful to be sure that you line everything up. So the first move it does will always be a positive Z move, so it doesn't inadvertently turn the laser on. And that's it. It just friggin' works. Any CAM software, it's the simplest G code. Any CAM software will work. It's all 2D stuff. Period. Bada boom, bada bang. So this kind of laser, any of these cheapy Chinese guys, homemade, anything you got, it'll work. It'll work. So there you go. That is how to run your laser cutter off of Mach 3 flawlessly without any plugins or any BS or any profiles or any crap. It just works. Period. Done. Done.